Hello viewers, and welcome back to Fafana Maths class. We are still on the topic indices, and today we are going to look at a subtopic under indices called exponential equations. And then exponential equations are equations which have the variable or unknown quantity as an index or an exponent. So to solve such equation, we always use the fact that if you have a base to the power x and it's equal to the same number which is the same base to the power y, okay, we use the fact that if this base is equal to this base, we always see it to be the exponent 2 will also seem to be what? Equal. Okay, so based on this fact is what we use in solving exponential equations. Okay, so the unknown variables are made or are looked for as their exponent, okay, and then the bases will be made the same. If they are made the same, automatically the exponent too are also the same. All right, so now a quick example is if you have 3x to the power, say 3 to the power 2. All right, so if you have this base to be the same as this base, so the equal sign which is separating them is telling us that this base is equal to this base. So if it is so, then the fact or the rule of the exponential equation says that if the two bases are equal, then their powers too are equal. So x will be equal to what? 2. All right. So in expressing it, if you have 3x equal to say 9, all right, what you have to do is to make sure that the bases are equal. Then you equate the exponent and solve for your unknown variable. So this 3 to the power x will be equal to 9. How can we resolve this 9, or how can we simplify this 9 in order to get the same basis? We know that 3 to the power 2 will give us 9, right? So 3 to the power 2 giving us 9 means that this 3 and this 3 are equal. Therefore, the basis to the powers are also what? Equal. All right. Now let's look at another example. If you have 64 to the power x and it's equating to 16, all right, how do we do this? Now we have 64 to the power x and then we have 16 to the power 4 to the power 1. All right, I told you any number standing alone without any assigned power is power 1. All right, so now 64 to the power x, how do we get it? How do we simplify to get the same as this 16? 16 square will not give you 64, so you need to come down a little bit to say 4. All right, because we know that 4 to the power 2 will give us what? 16. Then if 4 to the power 2 will give us 16, 4 to the power what will give us 64. Okay, so let's see if 4 to the power 3, 4 to the power 3 will give us 64. Now let's check. So 4 times 4 times 4. All right, so 4 times 4 we have what? 16 times 4. So 4 times 4 here, 4, 6, we have 24, right? So 4 remainder 2. 4 times 4, 4 times 1, we have 4 plus 2, then 6. So it means we are correct here. Okay, so from the rule, from the last rule, the third rule or the fourth rule of indices, it says that if you have any expression like this, you can express it like, you can let the x outside, okay, or the exponent outside the bracket multiply the exponent inside the bracket. So we have what? The power 2. All right, this one you could go further and then bring this one down, but since you could have the same answer as when you do it, you leave it like that. Okay, so you have what? 3x equating to what? 2. All right, so when you divide both sides by 3, you have x to be equal to what? 2 over 3. All right, so from here what I mean is we can also express this one, or we can bring it, deduce it down. 2 we know is a perfect, 4 we know is a perfect square of 2. So 2 to the power 2 times this will give us this value. Okay, so equal to what? 2 to the power 2 times 2, like this. All right, so we could have what? 2 times 3x equating to what? 2 times 2. Okay, so 2 times 3x we have what? 6x equal to what? 4. All right, so when you divide this one by 6, here 2 by 6, we could have what? X to the power 4 over 6. All right, 2 will go here 2 times and it will go here what? 3 times. So at the end of the day, you realize that we have what? The same answer as this one. Okay, so they all give you the same answer. Now let's take one more example on this topic. We have 3 to the power 2x minus 1 equating to 1 over 81. All right, 1 over 81. 1 over 81, remember I said in the notifications in our previous video that if you have a number and it is raised to the power negative, it has a special way of expressing it by reciprocating the base. But here is the case that we have the opposite of that statement, which says that we have what 1 over it is already reciprocated. So it means originally this value 1 over 81 was what 81 raised to the power negative 1. All right. So here we have 3 to the power x minus 1. So how do we turn this 3 to the this 81 to the power negative 1 to get base 3? All right. We know that 3 to the power 4 will give us 81, right? We have 3 times 3 times 3 times what? 3. 3 will give us 9. 9 times 3. 9 times 3 we have what? 27. 27 times 3 we have 81. All right. So this is how the thing is done. All right. So we have 81. So it means 3 to the power negative 4. All right. Or 3 to the power 4 times negative 1. All right, so you're getting 3 to the power 2x minus 1 equating to 3 to the power negative 4. All right, so if you have base 3 here, we have base 3 here. The bases are the same, so we equate the powers, which is what 2x minus 1 equating to negative 4. All right, so we move negative 1 to this side to get what? Positive 1. So we have what? 2x equating to negative 3. All right, so if you have 2x equating to negative 3, we can choose to divide both sides by what? 2, here by 2. This 2 will take out of this 2, so x will be equal to negative 3 over 2. All right, so this brings us to the end of the exponential equations. Don't forget to like and then share for the benefit of others. Have a nice day.